hyperbolic and inverse hyperbolic function. So this is the theorem in inverse hyperbolic function, which is we have 6 theorems involved: sine hyperbolic inverse x, cos hyperbolic inverse x, tangent hyperbolic inverse x, cotangent hyperbolic inverse x, secant hyperbolic inverse x, and cosecant hyperbolic inverse x. So the hyperbolic function actually a rational function, which is e power of x, whose the numerator and denominator are of degree at most 2, and e power of x in terms of quadratic formula. Then we need to take it into the natural logarithm in order to express the inverse hyperbolic function. Okay, so let we look how to solve hyperbolic inverse hyperbolic function. So we have example 1 to show sine hyperbolic inverse x is equal to ln x plus square root of x squared plus 1. So first step, we need to let our y is equal to sine hyperbolic inverse x. So from this, we change the position first. So x move to the left and y move to the right. So what will happen now? So our x is equal to sine hyperbolic x. Okay, so when we change the position, inverse we move also. Okay, inverse function we change to hyperbolic sine hyperbolic y. So from here, our x is equal to sine hyperbolic x. So sine hyperbolic x is we refer from our table of sine hyperbolic or hyperbolic function. So sine hyperbolic x is equal to e power of y minus e power of negative y over 2. So from here, if we take two functions here, which is x and e power of y minus e power of negative y over 2, then we will get 2x, we move to the left. So 2x is equal to e power of y minus e power of negative y. So we rearrange, we make our function is equal to 0. Then we will get e power of y minus e power of negative y minus 2x is equal to 0. So we multiply both sides with e power of y because we want to cancel the function of e power of negative y here. Which one we want to move? Okay, so that we multiply all both sides, right and left hand side, with e power of y. So when we multiply with e power of y, we will get e power of y multiply with e power of y minus e power of negative y multiply e power of y minus 2x e power of y is equal to 0. So from here, we simplify the function. We will get e power of y power of 2, okay, minus this one. When we minus the negative y plus y, so we get 1. So e power of 1, then we will get e power of negative y plus y is equal to e power of 0. So e power of 0 is equal to 1. So this we will get 1 here. Okay, then at the back we just write down back to x e power of y is equal to 0. So from here, we rearrange this function. Okay, we rearrange first. E power of y square minus 2x e power of y minus 1 is equal to 0. So it's like that our function. So this for x square, this for 2x. Okay, so we have same variable that we change the variable. Let's say this is y, so this is y square, where 2x y minus y equal to 0. So it's like that. So if we find our a, b and c, we can find the constant in front of y square is 1. So our a is equal to 1. Okay, this one minus. So our b is equal to negative 2x. Then our c is equal to negative 1 here. So we need to solve by using the quadratic formula. Okay, in order to solve the equation, we need to use using quadratic formula. Okay, so we will get e power of y. Okay, so this one e power of y. We want to find e power of y here. So our e power of y is equal to negative b plus minus square root of b square minus 4ac over 2a. Okay, so remember what is our value for a, b and c from this one. So we will get negative 2x plus minus square root of our b, negative 2x square minus 4 times a times c negative 1. For ac. So over negative 4 2a. So 2 multiplied with 1. 4a 1 negative 1. Okay, so from here we will get our function is equal to 2x plus minus square root of 4x square plus 4. So we can factorize number 4 here. Yes, here I change first. So we factorize number 4 over 2. Sorry, this is over 2 here. So 2x plus minus square root of 4 multiplied with x square plus 1 over 2. So equal to 2x plus minus 2 square root of x square plus 1 over 2. So we factorize again x plus square root of x square plus 1 over 2. Or our final answer, we will get, we can cancel 2 at numerator and denominator. So we will get x plus minus square root of x square plus 1. Since let me write down the final answer at the bottom here. So since e power of y must be greater than 0. Okay, y greater than 0 because in ln. Okay, ln must be greater than 0. And x minus square root of x square plus 1 also must less than 0. So it cannot be less than, because the minus sign is, okay, minus sign is inadmissible. So therefore we assume that our e power of y is equal to x plus square root of x square minus 1. Or from here, we want to take our y. So what happened to our y? We need to add ln. Okay, we need to add ln in order to move our y in front. So we multiply all here with ln. So y ln e is equal to ln x plus v square root of x plus 1. So ln and exponential we can cancel. So our final answer is equal to y equal to ln x plus v square root of x plus 1. But don't forget to write down ln modulus. Okay, if you have a final answer of ln, so you need to add modulus there. Okay, next we look at example 2. Find dy dx for the following equation. So from here we want to find the dy dx. Okay, but let me look at table first. Okay, so this is the table of differentiation for inverse hyperbolic function. So from this table we need to look at the question first. So we need to solve of cotangent hyperbolic inverse 3x squared. So in order to differentiate this function, okay, cotangent hyperbolic inverse 3x squared, so we will get equal to, look at the table back. Okay, table for cotangent is number 4 here. Okay, so number 4, cotangent, when we differentiate, we will get 1 over 1 minus u square multiplied with du over dx. Okay, so for this case, our u is equal to 3x squared. So if you confused, you just write down back. Our u is equal to 3x squared. Then you will get du over dx is equal to 6x. So the answer is 1 over 1 minus u square. So 1 minus u is 3x square, then we square again. Okay, multiply with du over dx. So du over dx is 6x. So when we simplify this, we will get 6x over 1 minus 9x power of 4. So this is the final answer for step number 2, question 2. Okay, let me look at next question, which is we need to differentiate cos hyperbolic for 2x plus 1. So how to solve this one? So first of all, we need to differentiate cos hyperbolic inverse 2x plus 1. So look at our table back. Okay, what is the differentiation of cos hyperbolic inverse? So look at table, this table number 2. So we will get 1 over square root of u square minus 1. Okay, so 1 over square root of u square minus 1 multiplied with du over dx. Okay, this is what we get from the table. Okay, so first of all, we need to identify our u first. So this is our u. So let our u is equal to 2x plus 1. So du over dx is equal to 2. Okay, so to differentiate this, we will get 1 over square root of u square. So what is our u? 2x plus 1 square, then minus 1 multiplied with du over dx, which is 2. So when we multiply 1 and 2 here, we will get 2 over square root of 2x plus 1 square minus 1. So this is answer for question 2. Okay, let me look at the question 2c. So for this case, we need to differentiate cos hyperbolic inverse x over 3x. So for this case, we have u over v. So u over v means we need to differentiate quotient rule. Okay, so the formula to differentiate this one is dy over dx. Basically, we have dy over dx is equal to v u prime minus u v prime over v square. So what is our u here? So our u, okay, let our u is equal to cos hyperbolic inverse x, and our v is equal to 3x. So after identify our u and our v, we need to differentiate the function. So differentiate cos hyperbolic inverse x, we will get 1 over square root of u square minus 1 multiplied with du over dx. This is the formula for differentiation of cos hyperbolic inverse x. So our u is equal to x, so we just plug in our u, x square minus 1, so du dx. When we differentiate x, we will get 1, so just multiply by 1 here. Okay, so v prime is equal to the differentiation of 3x, we will get 3 here. So in order to differentiate this, okay, so let me differentiate this one. So our differentiation of cos hyperbolic inverse x over 3x is equal to vu prime v 3x vu prime 1 over square root of x square minus 1 minus with u v prime. So u is cos hyperbolic inverse x multiply with v prime. V prime is 3, so we can put in front also. So over v square, so our v is 3x, we just square this function. So our answer should be 3x over square root of x square minus 1 multiply with 3 cos hyperbolic inverse x over 3. Sorry, when we expand 3, we will get is equal, this one is 9x square at our denominator. So this is the final answer for this function. We just left our answer until here. Okay, so next, let me look at the next example. Okay, example 2, we have d is equal to 2xy. So this one involve implicit function. So this one involve sine hyperbolic, okay, hyperbolic inverse hyperbolic function. So first of all, we solve for the left hand side first. So left hand side and right hand side, we need to differentiate one by one. So if we differentiate 2xy, we will get, okay, this one we differentiate 2xy. So that we put our u is equal to 2x, then u prime is equal to 2. Okay, our v is equal to y, so our v prime is equal to 1. So the formula for this one is u v prime plus with vu prime. Okay, so we just differentiate by using the product rule, differentiation of product rule. So u v prime, u 2x v prime 1 plus with v y v u prime 2, okay, is equal to, when we differentiate, sorry, not 1, dy dx. Okay, so this one is dy over dx. Okay, so when we differentiate sine hyperbolic inverse tangent y, we will get 1 over square root of u square. So our u is tangent y here. Okay, so our u is tangent y, so 1 plus tangent square y, because the formula is 1 over square root of 1 plus u square multiply with the differentiation of tangent y. So when we differentiate tangent y, we will get multiply with second square y dy over dx. Okay, so we want to only d1 dx in front, so we just bring all dy dx to the left hand side. Okay, so we move second hyperbolic here. We move second hyperbolic, second square y to the left hand side because this is dy dx. Okay, when we factorize already, we factorize. Okay, so what left when we factorize dy dx, we will get to x minus with second square y over square root of 1 plus tangent square y, close the bracket, and equal to negative 2y. So we only want dy over dx here, so that our final answer should be dy over dx is equal to negative 2y over the whole thing here, 2x minus second square y over square root of 1 plus tangent square y. Okay, 1 plus okay, 1 plus tangent square y. Okay, so from here, if you want to simplify, 1 plus tangent square y, you can see this is equal to actually 1 plus tangent square y. Actually, this one is equal to second square y. Okay, so we can simplify this one by using the formula. So if we want to simplify, then we will get dy over dx is equal to negative 2y over 2x minus second square y over second square y. We need to divide one by one, so only this one. Okay, this one over square root of second square y, because 1 plus tangent square y is equal to second square y. So this one we can cancel, so we have second square y over second square y. Okay, so that we will get here negative 2y over 2x minus with second y. So this is our final answer. Okay, next we look at the next question. Okay, this one for E. Sorry, I have done previously, so that I erase first the answer. Okay, so for this case, we need to differentiate for both sides, left and right hand side. So we differentiate one by one. Differentiate for sine hyperbolic inverse y must be differentiate also for d for x squared over dx plus with d over dx differentiate to xy. Okay, so from here we differentiate sine hyperbolic inverse. Okay, so when we differentiate sine hyperbolic inverse, we will get 1 over square root of 1 plus y square dy over dx, because our angle is y here. So then we differentiate for x square, we will get ax. Then we differentiate to xy, we will get, okay, this one is u and this one is v. So we will get plus uv prime. uv prime plus vu prime. Okay, so then we bring dy over dx. Okay, which one? With dy over dx, we move to the left. Then we factorize. From here we factorize our dy over dx. 1 over square root of 1 plus y square minus 2x is equal to 8x plus 2y. Okay, so from here we only want dy over dx, so we just write down our dy over dx, then we divide this one. So 8x plus 2y over 1 over square root of 1 plus y square minus 2x. So this is our final answer. Okay, next. Okay, so next, let me look at the question. So, question A. Okay, example 3, question A. So we have 1 over square root of x squared plus 9. So how to solve this one? Okay, first of all, we need to identify our x and our u. So u is equal to x squared. Okay, so our u, let our u is equal to x, then we simplify. Du over dx is equal to 1. Okay, when we cross multiply, we will get du is equal to dx. Okay, that's why our a squared is equal to 9, a is equal to 3. So from the above question, integration of square root of x squared plus 9 dx, we will get equal to integration of 1 over u square plus with 3 square multiplied with du. So from here we can look at the table back. What is the formula for this function? Okay, sorry, they have a square root there. Okay, so if we look at the table previously, which function of the table will give us the same answer? Sorry, not this one. Okay, this table. Okay, if we look at this table, which table have 1 over u square plus 1 plus a square? U square plus a square. Okay, it seems like this. Okay, so we can take sign hyperbolic inverse u for our answer. Okay, so from here we can take the answer is equal to sine hyperbolic inverse x over 3. Okay, because our a here is 3. Okay, this one have a value of 9. Okay, so this is the example of 3a. Next, we look at example of 3b. So for this case, we need to identify our u and our a square. So let u square is equal to x square. So u is equal to x. Then du over dx is equal to 1. So a square is equal to 16. Then a is equal to 4. Okay, so from here, we can solve this question. Okay, so integration of 1 over square root of x square minus 16 dx should be equal to 1 over square root of u square minus 4 square du. Okay. Okay, so from this we look at table previously, we will get cos hyperbolic inverse u over a plus with c. So what is u over a? So cos hyperbolic inverse u over a, our u is x, then our a is 4, then plus with c. So this is our final answer for this question. Okay, next we look at question C. So first we let our u square is equal to 4x power of 4, or our u is equal to square root of 4x squared. Then we solve, we will get 2x only. Okay, so from here, 2x squared. This is power of 4. Okay, so this power of 4, so 2x squared left. Then our du over dx is equal to 4x. Okay, So we change the position. So we will get dx is equal to du over 4x. Okay, so for this case, when we integrate this function, we will get integration of 2x over 1 square. Okay, don't forget to write down square root 1 square plus with 4x square, which is 4x square is u square du. Okay, so du is equal to dx. Sorry, this is dx. Actually, we need to write down du, but from here we have dx. Okay, so we change the value of dx with du. So integration of 2x over square root of 1 plus u square, then our du is 2 du over 4x. So sorry, there has no number here. So if we simplify this as xn, so 1 this 2, then we will get 1 over 2 square root of du over square root of 1 plus u square. Okay, so from this we will get equal to 2 sine hyperbolic inverse u over a. So our u is 2x square over a. A is equal to 1 plus with c, because there are no number at the integration symbol, so we just no need to write down 1 here. Okay, we can cancel the value of 1. So let me cancel first value of 1 here. So actually it have, but we already cancel the value. Okay, next we want to do for 2 over square root of 3x square minus 4 dx. So first of all, we let our function first with u and a. So u square is equal to 3x square. So u is equal to square root of 3x square. Okay, then we will get du over dx is equal to 1 over 2 3x square. 1 over 2 du over x. 3x square negative 1 over 2. Okay, square root of x, or we simplify first this. Okay, if you don't want to do like this, you can simplify first. You will get from here square root of 3 multiplied with x only, because square root of x square is equal to x power of 1 over 2 multiplied by 2. So when we cancel, it left equal to x. So we find u dx, we will get square root of 3 here. So we change the position, dx up to the above. So what we will get is du is equal to dx is equal to du over square root of x. So square root of 3. Okay, so this is our dx. Okay, then from this formula, you just plug in the formula of 2 over square root of u square minus a square dx. Okay, then we compare to the table. Okay, what is the value which is same like this? Okay, or then we can replace the value of dx. Okay, multiply with dx. So dx is du over square root of 3. So we just move down 2 over square root of 3, integrate of 1 over u square minus 9 square du. So from here, we can know this is the formula for cos hyperbolic. Okay, so the constant in front you just write down back. So cos hyperbolic inverse u over a plus c. So our u is equal to square root of 3x over 2 plus with c. Okay, so this is answer for TD. Okay, let me look at example suitable here is 3A. Okay, so for 3A, we need to completing square first. So completing x square minus 2x plus with 5. So we will get x square minus 2x plus with 5, which is equal to, when we factorize, we will get x minus 1 square minus 1 plus with 5. So is equal to x minus 1 square plus with 4. Okay, so from here we integrate the function. Okay, so when we integrate the function, we will get 1 over, integrate of 1 over x minus, x minus 1 square plus with 4 multiply with dx. Okay, so this one, our u is equal to x minus 1 square. So u square is equal to x minus 1 square. Our a square is equal to 4, then a is equal to 2. Okay, so from here, our u is equal to x minus 1. Then du over dx equal to 1 only. Okay, so we just substitute into the given formula, which is 1 over, integrate 1 over u square plus with 2 square dx. So this is integration for sine hyperbolic inverse u over a plus with c. So what is u over a? So let's back the original question, which is our u is x minus 1 and our a is equal to 2 plus with c. Okay. Okay, so this is the answer. Okay, next, let me look at example F. Okay, so we need to identify first what is our u. So that u is equal to cos inverse x. Okay, so du over dx. Du over dx is equal to negative sign. So this is negative sign. Okay, so after we identify our u, we can substitute the formula. So we need dx, so dx is equal to du over sine inverse x. Sorry, we have negative here. Okay, so when we integrate this, we will get integration of sine x over square root of 1 square plus u square multiply with du. So we integrate with sine x over our u. What is our u? This one du over sine inverse. Okay, sine inverse. Sorry, not sine inverse. Cos inverse. Sorry, u is cos. Sorry, there are no inverse at the top. So what we get is sine x only. Sine x. That's why we can cancel sine and sine. So we have 1 square plus with u square dx. Okay, so from here we know the inverse hyperbolic function for this function is equal to sine hyperbolic inverse x over a. So our u is cos x over a. So a is 1 because we didn't have a here. So you just left without a because we didn't have a. It's maybe 1, it's maybe greater than that. So to be secure, you just left like this. Okay, next, number E. Okay, please change this function 1 over x squared of 9 minus x squared dx. Okay, so from here we let our u first. So our u is x squared. U is equal to x squared. Du over dx is equal to 2x. So we change the position. Dx is equal to du over 2x. Okay, then our a square is equal to 9. Our a is also equal to 3. Okay, so from this we can substitute into the formula. Okay, sorry, this is the formula. Okay, so formula for this one we will get is equal to integration of 1 over symbol x square of 3 square minus u square du. Okay, we want only 2 words, right? So it will give us dx. So dx is equal to du over 2, because we have 2x here. Okay, we can solve for x we put later on, and then this is our function. This will become like 2x over 3 square minus u square. 3 square minus u square. Sorry, this is 3 square minus with u square multiply with du plus with c. Or we will get 1 over negative 1 over 3 second hyperbolic inverse 2x over a. 2x over a, which is a equal to 3 plus with c. Okay, so this is the answer for this question. So we have another several question, so you can try by your own.